it's okay. We're going to learn today, and we're going to try and look at the rules and what it is that we need to know for Euclidean geometry, just to make sure that we're understanding the concept. And guys, you absolutely need Euclidean geometry. There's a section in Euclidean geometry called circle geometry when you get to the older grades, and this is the building block of circle geometry. So we need to know this very well. Okay, all right, let's start with an easy question. All right, who can remind me, guys? Hi, Anotida. Okay, let's start here. Who can remind me, what does this thing here in the middle mean? What do these three lines here mean? I see some people saying congruence, others saying similarity. Which one is it? Which one is it? You're very welcome, my dude. Good. All right. This one is actually congruence, right? It's congruence. And congruence does come up quite often. So we're going to see it a lot, especially in this section that we do on quadrilaterals, which is what we focus on in Euclidean geometry in grade 10. So this is congruence. And what we do know about congruence, guys, is that if any two shapes are to be congruent, they need to be 100% exactly. I don't even want to say the same because it sounds too close to similar. I want to say exactly identical. They must be identical. Like if they were twins, you couldn't tell them apart. Okay. They must be identical. So they must have the same type of side. They must have the same type of angle. The orientation doesn't matter that much. It's like they don't all have to be facing up, but they must have everything that's about the same. All right, so the next question over here says to us, prove that triangle DEF is congruent to triangle GHK. And what we do remember, guys, is that the order in which we write our triangles is incredibly important because it maps out the way that we need to answer this question. All right, so remember, guys, we're always going to look for a statement and a reason, and here's what we're going to do. We're going to make sure that we are mapping our triangles out properly. So I'm going to start my proof. I'm going to write here. Oh, my pen is acting funny today. Okay, I'm going to write proof. In triangle DEF. Now, I want you guys to be very, very careful about what order we're moving in Ayanda before we even get there. Okay, and triangle. Now, if we started at D, we started at an angle 30 and we went to the 75-degree angle, then we went to F, DEF. We need to start somewhere and then go to the 75-degree angle and then come back to that one. So when we map out the other triangle, that's it in Kechi, we need to say triangle GHK. And we do this because we need to make sure that when we are proving congruence, we're doing it in the correct order. Now, before we even get to what Ayanda said, and Ayanda, you are on point, we can say that it's not that it's given, we first have to prove it. And only after that can we say, we don't say given, we're going to say proved above. All right, so here's what we know. We know that this and this tells us that GH and GK are the same length. What kind of shape do we then know, or what kind of triangle is triangle GHK, guys? Tell me, what kind of triangle? That's it in Kechi. I just want everybody else to catch up with you. Good, Nicole, excellent. It's an isosceles triangle. Good, it's isosceles. Isosceles. I like writing that word. It sounds very fancy. All right, isosceles triangle. So I know that if angle H is equal to 75, what does that make angle K equal to? Good. Eunice, be very careful. Remember the base angles. That's it, Isabel. Excellent. That's it, Ritsepile. That's it, Caitlin. The base angles will always be equal to each other. So this makes this 75 degrees. So before we even get into writing anything about the proof, we're going to start by putting this thing in order. We're going to start by saying angle K is equal to 75 degrees. And our reason for that is not, we're not going to write isosceles triangle. They do not allow isos triangle anymore. Okay. They keep flip-flopping forward and backwards, but I know that the actual reason that they're looking for is opposite angles equal side. That's it. Okay. Opposite angles equals side. Equal side. Okay. Well, all that means is if the opposite angles are equal, then the sides, the base angles of those things will also be equal. That's it, Caitlin. Okay, good. So now we know that angle K is equal to 75 degrees. Now we can calculate for G. What is the angle for G, guys? How much is G? G is equal to what? Good, Isabel. That's it. Then angle G will be equal to 30 degrees. Good. And we need a reason for this. What is my reason, guys? Anybody? It's not given. Good, Nicole. That's it, Nkechi. It's not given to us. Be very, very careful, Kanyisile. They haven't given it to us. We've calculated it. So this is the angles sum in a triangle. Okay, good. It's the angles that make up the sum of a triangle. So angle sum in triangle. Okay. Now we've got some stuff that we can look at, right? So we can say this is 30 degrees. Good. Now we can start by comparing two things each in every triangle, right? I'm going to start by saying, shoot, my pen is acting kind of funny here. All right. Now I'm going to start by saying angle D is equal to angle what? Which angle is angle ED equal to? Good. Angle G. Chifaro, what kind of sign? Good. And our reason here, normally we would say given, right? We would say given if they had actually given it to us, but they didn't give it to us. We proved it. We figured it out. So instead of writing given, we are going to say it's been proved above. Okay. Or solved above. You can say proved above or solved above. You get to pick which way that you put this. Okay. So we say angle D is equal to angle G, right? Now that is true. We can see it in the way we've mapped out our triangles. Angle D is equal to angle G, right? 100%, though we've done it in the correct order. Now I want us to see DF. If I have DF, guys, DF, which side will DF be equal to in the other triangle? Okay, be very careful, guys. Look, I've jumped. That's it, Oratilwe. I've went from D right over F. Bongani, tell me, which angle is D, which side is DF equal to? I need you to swipe left or right, look for a big speak button, and you can unmute for me. Hi, Bongani. Hello, Bongani, I can hear you. You just need to speak.
Hi.
Hello. Can you tell me, Bongani, DF is equal to which side? DF is equal to?
GK.
Beautifully done. Good. GK. What is our reason this time, Bongani?
Given.
It's given. Yes, that's it. Good. Good. It's given. Mwah. Beautifully done, my dude. Excellent stuff. Beautiful, beautiful. All right. Very well done. Now we need one more reason, guys. We've got two reasons. What is our last reason going to be? Over here, we figured out that we've got an angle. And over here, we've got a side. Ayanda, in this case, for that one thing that we did, it is. Okay, because they did tell us in the drawing that this side is equal to this side. So we're allowed to say that. Good. Okay, we've already done angle D and angle G. Which two other angles are equal to each other? Guys, look at the way we've mapped out our triangle. Right. Angle E must be equal to angle, that's it, Kanyisile. Beautiful, is equal to angle H. And that is also given to us. We didn't have to calculate for that. They've given that to us. So we can then say angle E, sure guys, I need to figure out what's going on with my pen. All right, angle E is equal to angle H. And that is given. Good. Now we've got 3 reasons. I've got it exciting. There we go. Right. Now I can say, therefore, triangle DEF is congruent to triangle GHK. Now let's look at our reason. GHK. Let's look at our reason. Okay, we've been given a side and an angle and another angle next to it. Okay, same over here. They've given us a side and an angle and another angle next to it. Right, so our reason is going to be good. Beautiful, Bongani. That's it, Nicole. Well done, Anotida. We are looking for side, angle, angle. Right, now I want you guys to pay careful attention. Just because we wrote these down in the order of angle, side, angle, it does not mean that the actual reason is angle, side, angle. No worries, Amkhalang, welcome. Okay, just because we prove them in that order, it doesn't mean that's the order that they actually give it. That's not the actual reason. Okay, so Nkechi, watch why it's not side, angle, side. Look at this first triangle that they've given us over here. Let's look at this first triangle, triangle DEF. How many sides have they given us, Nkechi? They've only given us one side. So it can't be side, angle, side, because we would need another side. Okay, and they haven't given that to us. Okay. Not in this case, Oratile, sides in proportion is for similarity and not for congruence. Okay, so it can't be side, angle, side. It also cannot be angle, side, angle. It can't be angle, side, angle, because what we would need, guys, is we would need an angle, a side in between, and an angle. We also don't have that. Okay, we also don't have an angle and a side in between. So the only reason that we can use is that they've given us an angle, a side, an angle, and another angle next to it, right? It's the side with an angle and then the other angle next to it. So our only reason in this case is side, angle, angle, or we could have said angle, angle, side. Okay, those are our only 2 options here, either angle, angle, side, or side, angle, angle. Give me a thumbs up if you understand why I've reasoned out the reason for congruency the way that I have. Okay. Give me a thumbs up if it makes sense. Okay. Excellent. All right. And to answer Oratile's question, Oratile, the reason why we can't use angle, angle, angle for congruency is because our triangles need to be identical. They need to look exactly the same. But now if I use angle, 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 I could have a triangle this tiny and a triangle this big, and they would have the same angle. Okay, this angle would be 40, and this one would also be 40. This angle would be 80, and this angle would be 80, and this angle would be 60, and this angle would be 60. Are these 2 triangles congruent? Are they identical? Are they identical? No, not at all. They are not identical, so they cannot be congruent. They are similar though, because they have matching angles. Okay, so for these 2 triangles, our reason would then be angle, angle, angle. But that doesn't mean that they are congruent. They're not congruent they are similar. Okay, that's the difference between congruence and similarity. Our congruent triangles are the same size and they have the same angles. They're also the same size. But our similar triangles don't have to be the same size. Okay, that's the difference. Okay, so in this case, Oratile, our reason is angle or side angle angle, or if you would like, instead of saying side angle angle, you can say angle angle side. Okay, whichever one, both of them work. Yes, we only use angle 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 for similarity and not for congruency. Thank you, Teacher Knowles, for that. All right, excellent, guys. Now let's move on to our next question, right? Now, look at what they've said, right? They have given us, you're very welcome, Oradile. Okay, keep those questions coming. We want to make sure that you're not left behind, we understand. Okay. All right, so our next question here says, we have been given two triangles. We've been given triangle ABC and triangle CD. And then they say to us that AC is equal to DE. So I'm going to go in and put this down. I'm going to say AC, that one, is equal to DE. Good. What other information do they give me, guys? Read it out. Have a look. What other information have they given me? Have a look, guys. Read the information on the screen and tell me, what else have they told us? Good. That AC is equal to DE. Good. BC and CD are equal. That's it, Nkechi. Excellent. BC and CD are equal. I see somebody else telling me that angle E is equal to X. Beautiful. They've told us that as well. They've also told us that. I just need to add this in. BC, which is the one down here, BC is equal to CD. That one and that one are equal. Okay, good. And then they've also told us that angle D is equal to 30 degrees. Good. They've put that in there. Angle D is equal to 30 degrees. Good. And then they tell us that AB is parallel to CD. So we can do this. Good. And I already saw one of you, I saw somebody already say something about alternate angles, 100%. Okay, somewhere along the lines, Aseza, we're going to use that. Okay, Remufilwe, you and Aseza are just like a power couple right now because you guys are saying the right things. Good. Good, Ayanda, that DCE, the angle DCE, which is this angle over here, is 2 times angle, is 2x, which means it's 2 times angle E, right? So who wants to venture? What is the first thing we're going to look at? Does anybody want to know? Remember, guys, we first need to determine the value of X. We need to determine the value of X. How are we going to determine the value of X, guys? 4.2.1. Ooh, not fun. Think about it, guys. Think about it. Okay. Anybody? What kind of shape? Yes, good. Who said that? Who said that? Ivana. Hi, Ivana. Hi. Good. No, not so much the straight line. Not so much the straight line, Nicole, because we don't know what this angle is. But Ivana is onto something. Okay, Ivana's onto something. Ivana's saying something about a triangle. And we should note that this thing over here is a triangle. Nkechi, I'm going to explain what fun means in just a second. Okay, we're going to explain what fun means. All right, so we can use the interior angles of a triangle. I would like a volunteer. Anybody want to unmute and let me know how to calculate? Didi, you might as well put your hand up. All right, there we go. Didi, Anotida, how are you doing, my dude?
Oh, I'm doing fine.
Okay, excellent. You're going to have to give me a statement and a reason to prove for 4.2.1. Are you able to do that?
To calculate X.
Yes, we are calculating for X.
Oh, wait, which X are we actually talking about? Because there's one in the triangle and there's one on the outside.
Exactly. Both of them will be the same thing. Okay, so what they mean by x is if you figured out the value of that one, you've automatically figured out the value of that one. Okay, so you only need to find one of them for us.
Okay, so then that means, okay, what am I gonna say here? Since, let's see.
I'll give you
Are we gonna use alternate angles here?
Not
For
quite,
the
because we don't have any information in the other triangle. What do you think we can say here?
How about this? Can we say a 2x plus x plus 30 degrees? It's possible if we can do it like that.
Is equal to?
Is equals to 180 degrees.
Beautiful. What is our reason?
Sum of angles in triangle.
Beautiful angle sum in triangle. That's it. And now we can figure out what x is. Yes? Let's just reshuffle things a bit. So what would I write next?
Okay, so we're gonna say, can we say this 3x is equals to 180 degrees minus 30 degrees?
Okay, we're gonna skip a step because we're grown now. So just go ahead and minus 30 degrees from 180, and what are we gonna get?
150.
150, excellent. Next step?
150 divided by 3 on both sides.
That's it.
Let me see that. Right, 3 is gonna give us 50 degrees.
Good.
X is equals to 50.
Excellent. Yes. So what you've actually told me here, Anutida, is that this x over here is 50 degrees. What do we know about this x over here?
Which one?
This one here in the middle.
How can I say this?
If this one is 50, this one will be?
Could be 30, maybe.
No, it's 50 because if this 50. One is x, this one is x, they share the same value. Okay, so if this one is 50, this one is also.
See that. I did not see that. I just saw it just now. Sorry, the parallel.
Okay, no worries, no worries. We figured out that x is 50 degrees. So if this x over here is 50 degrees, that means this one is also 50 degrees. What about this 2x over here? 2x would be?
2x would be, let me quickly see that. Could it be right? 180 minus. What? Okay. Hold on. Okay. Could it be 100 degrees?
It is. It's 100 degrees. Excellent. Very nicely done. Beautifully done. Excellent.
My calculator
you think they're trying to trick you, they're not trying to trick you. Okay. The answer that you were thinking is the correct answer. All right. Very well done, dude. Excellent stuff.
Thank you very much.
Nicely done.
Welcome.
Awesome. All right. I see somebody asking, ma'am, where did we get the 3x? All we did was we went 2x plus x equals 3x. And that's where we got that 3x over there. And then we took 30 over to the other side and it became minus 30 degrees. 180 minus 30 degrees gave us 150. Okay. So we just took the steps one, like quickly, very quickly, instead of one at a time. Yes, Nkechi.
Ma'am, so what would happen if in that triangle there was only like x and 30 degrees? Like there wasn't like a third one?
Then they wouldn't have given us enough information to do what we need to do. Okay. So every sum, whenever it's given to you, will always give you enough information to do what you need to. Okay.
Okay. Thank you.
All right, Ms. Lee. Okay, good. Now we've established a couple of things, right? We've established that the value of x is 50. I want to ask you guys, what is the value of angle A? And I want somebody to give me a reason why the value of angle A is what it is. Or actually, where did the 100 come from? This is 2x. 2x is 2 times 50. Okay. All right. Yes, Sipokazi.
So, ma'am,
Yes.
isn't the angle A 50 degrees and the reason is alternating angles?
Mwah. I would give you all the flowers, sweetie. Beautiful. There's my Z there. There's my N from fun angles. There we go. There's my N. You are a whole rock star. Very well done. That's exactly what I wanted to hear. Sure. Just you guys are my whole life. Love, love, love it. Excellent. All right. I saw many of you guys asking, what are fun angles? All right. So we've learned, for those of you who are joining us for the first time, we've learned that if they have ever given us, if they ever give us that something is parallel to something, we need to automatically go to fun angles. And fun, this F over here, let me draw a little bigger, just so that we can get an idea. Okay. Fun. There we go. All right. This F stands for corresponding angles because our corresponding angles would fall in between there. So this is corresponding angles. And the U in fun would be our co-interior angles. And the N would be our alternate angles. And all of these they stem from the idea that that side is parallel to that side, and that side is parallel to that side, and that side is parallel to that side. So if you ever hear us say there are parallel lines, therefore fun angles, it's because the FUN stands for corresponding co-interior and alternate angles. Give me a thumbs up if that makes sense. Okay, yes, that's it. That's it, Nkechi. Maths is fun. It is, especially when you understand. It's more fun when you understand. Okay, excellent. Okay, so if you see people saying fun angles, this is what we're actually referring to, guys. So trust me, fun angles are going to come up again. So remember the word fun. It's going to come up again. All right, now they say to us, guys, in this next question over here, it says, prove that triangle ABC is congruent to triangle ECD. Remember, the way we map them out is very, very important. We're going to start by saying proof. In triangle, now we need to go A, B, C. Make sure we're doing it correctly. A, B, C. And over here, guys, they've told us that side BC is equal to DC. So we can't start our triangle at DCE. That's not going to work. We need to start our triangle over here so that we have EDC, so that BC and DC correspond. So I then need to say in triangle ABC and triangle ECD. And the reason I want to write it out that way is so that when I get to the reason that they've given me, they've told me that AC is equal to DE, I can go AC is equal to ED or DE. Both of them are the same. All right, so we need to make sure we're mapping them out correctly, guys. And I feel like I've already given you the first reason that we're going to give to prove congruency. Guys, give them to me in the chat. What is the first reason we're going to use? I have Chipara. Good. AC is equal to DE. You guys are cheating. Okay, good. AC is equal to DE. What is our reason? We always need a reason, guys. Yes, that's it, Nkechi. They've given it to us. It's the information they've given it to us. I see what you did there, Nicole. Given. Okay, number 2. What is our next reason? Remember, guys, this is a side. Good, Ivana. Excellent. Good. BC is equal to CD. And our reason here is, what is our reason, guys? What's our reason for BC is equal to CD? Oratilwe, be very careful with that statement that you've just made. It's not true. It's not true. Side. It's been given. It's been given to us. Right. Now, the last reason that we're going to have here, guys, number 3, what is our last reason? Now, we cannot say that BC, or we cannot say that AB is equal to EC. They haven't told us that. They haven't told us. Kanyisile C is not the midpoint. Okay, think about what we know about these triangles. What else do we know, guys? Look inside both of the triangles. What do they have in common? Yes, good. E is X, right? So what do we know? Oh, Setu, you are on to something, but the two angles that you've named are not 100% correct. They're not 100% correct. Look at it again. Look at it again, guys. Okay, we now know that angle E, Tepile, yes, that's it. Beautifully done, Caitlin and Leah as well. Oh, Leah, not D. Angle A is equal to angle E. Good, Bunke. We proved that. We did. Okay, we just didn't write it because we proved it over here. We said that angle A is equal to X because of alternate angles. We'd already done it. All right, we'd already done it, and we needed to say that AB is parallel to CD. All right, we've proved it. We've done it already, proved. Right, and we know that that is an angle. Good. Now I've got my three reasons. I can then say that the one thing is parallel to, is congruent to the other. Can we say that D is equal to 30 degrees? Yes, we can, Isabel, but remember that angle D needs to correspond with angle C, and we don't know what angle C is over here. Okay. We don't know what it is, so we can't say that they are equal to each other. Gamo says ACD, alternate angles. ACD. Ah, okay, no, not quite, Gamo. Be careful with those kinds of statements. Okay. Yes, Isabel, remember, we are comparing two triangles. So we can't just say that because the other is 30, that means the other is automatically 30. You're assuming that they're already congruent, that we can't do that. All right, now we can say, therefore, triangle ABC is congruent. You're very welcome, my sweetie, to triangle ECD. Now, I know we've proved it as side-side angle. Side-side angle is not a reason. It's not a reason. Let's go have a look, guys. Let's go have a look. We need to make sure that we're naming this thing correctly. Okay, we need to make sure that we're naming it correctly. Now, we've said that AC, which is the side, is equal to DE. We've also said that BC over here is equal to that side. And we've also said that angle A is equal. So we can't actually use the reason that we've got here. We then have to go back, guys. We have to go back and we must find angle C. We must, because side-side angle is not a reason. We are not allowed to use side-side angle as a reason. And the only way we get to prove congruency here, guys, is if we use side angle side. But if we use side angle side, my angle needs to be in the middle, which means I need to have my angle in between my two sides. So my side, my angle, and my side. We need to figure out what angle C is. Remember, guys, side-side angle is the only one that is not a reason. So we need to figure out what C is. Anybody got any ideas? Tell me, guys, tell me. Who's got an idea? I need to now erase this part. Okay. Yes, Lutando, tell me. Teacher now says you've got an idea. Do you want to tell me what your idea is, Lutando? You can even raise your hand and we can have a conversation about it. Yes, I love to hear it. Excellent. Okay, I know, teacher, like you're using Teacher Nelly as a telephone right now, but you are on point. I think it's because Lutando DM'd you, and now instead of writing in the all chat, in the everyone chat, you're DMing Teacher now. It's good. We can have the fourth reason here. We can say, guys, angle C is equal to 30 degrees because of angles on a triangle. Angles on a triangle, angles on a straight line. Thank you. Yes, angles on a straight line. Angles on a straight line. Beautifully done. Good. Now we can then look at if angle C is equal to 30 degrees, which angle is it equal to, guys, in the other triangle? Now we can say that angle C is equal to which angle? Remember, E is 50 degrees, not 30 degrees. Beautiful. Angle C is equal to angle D. And we've just proved this. So we can say proved above or just proved, right? That's the angle we want. That is the angle we want to use. We can't use this one. That's the angle we need. Now, only now can we say, therefore, triangle ABC is congruent to triangle ECD. What is my reason, guys? I've got a side, and in between the two of them, I've got an angle. Be careful, Nkechi, how many angles do I have? How many angles do I have? No, actually, Nkechi is quite right. You can use angle, side, angle, or you can use side, angle, side. In this case, because we went through all that trouble, we're going to use side, angle, side, which is the correct thing to be doing in this case. Okay. All right. Also in the other triangle, side, an angle in between, side. Yes. Buntle, order matters. There is, Sipokazi, there is a reason called angle, side, angle. There is. But remember, Sipokazi, because if you use angle, side, angle, if you use ASA, what it means is you must have an angle and a side in between the two angles. So in this case, we would have an angle and a side in between. So Nkechi is also right. Nkechi's given us the correct answer. It's just we've used the other reason and we're allowed to use that reason as well. Okay. Not in this case, Sipokazi, not in this case. In the case of angle, angle, side, we can then do this. We have to go angle, angle, and then that side. Okay. So the order does matter, guys. It's very important that we do these things in the correct order. All right, give me a number out of 10. How are we feeling about this? How are we doing with this? Okay, Isabel says 6. Chifaro's quite comfortable. It's okay, Isabel. It really does take practice. Okay, for those of you who are still kind of struggling with this and you're like, you know what, I just need practice. I need to get used to it. All of these I've taken out of a grade 9 book. Okay. These are grade 9 questions. Okay, so this is something we should have gotten familiar with in grade 9. It's okay, Isabel, it does take a while. Okay, it takes a while to get used to it. Okay, so if you've still got your grade 9 textbook, go have a look at the geometry section in your grade 9 textbook. All of these are there and you're able to do them. Okay, Bunte, I will see if I can get you guys some homework. Okay. Oh, I see. And Oratile, we cannot do that. Hey, we can't. All right, let's talk about quadrilaterals, guys. And we're going to run out of time. Chifaro, no, we can't. We can't. We need to get this right first. All right. Now, the only thing I'm going to do here, guys, is I'm going to pause so that you guys can take screenshots because we're going to be using the properties that we're seeing in order to prove quadrilaterals. Okay. So take a screenshot, guys. Oh, before we continue here, I need to tell you guys that a square is a parallelogram. It's a parallelogram, all right? And there's a reason why I need to say this, okay? Because it is. And a rhombus is also a parallelogram. People using computers. Okay, take a screenshot. Okay, if you don't know how to do this, Nkechi, this is what you need to do. On your keyboard, right at the top, look for a button that's got this written on it. PRTSC. Okay, click on that button. Click on it. All right. As soon as you've clicked it, open up a Word document, right? Open up a Word document and then click Control and V. And then you'll see that this screenshot, even with ma'am's beautiful face, is going to come up. Okay. Okay. I hope that helped. I hope that helped, Nkechi. And Isabel, if you're using a computer, click Windows, Shift, and S. Yes, you can do that. There's a snipping tool, and then you can use the snipping tool to copy and then paste it to a Word document. All right. Excellent. Good stuff. Oh, Isabel, you're much better at this computer stuff than me. It took me forever to figure out that there was a snipping tool on my computer. All right. Okay, next screenshot. Here we go. All right. A kite is not a parallelogram. The other one that is a parallelogram is a rectangle. Okay. Take a screenshot, everybody. I was hoping Oratile would learn the maths, not just about taking print screens and screenshots, but it's fine. It's fine. You know, a lesson is a lesson. All right, guys, last one. Parallelogram and trapezium. Okay, now I want you guys to remember how all the other things that we've been told are also parallelograms. All right, Isabel, 1 second, everybody take a screenshot. I'm gonna explain in just a second, Oratile. Oh, no, I'm just saying, you're like, I learned something. I'm like, I hope you also learned maths, not just taking screenshots. I hope you also learned a little bit of maths today. Okay, all right, here we go. Is this where you need to be? There you are, Isabel. Kanisile, don't even think about it. Don't even think about it. We're not going there. Excellent, beautiful stuff. All right, guys, let's have a bit of a conversation. Now, we've got an example, right? This is what they've given us over here. Anotida, man. Ish. Okay, there's the kite. Hurry up, quickly. Take a screenshot. Okay. All right. Okay, Anotida, I'm moving. All right, done. Okay, excellent. All right. Now, this question over here says, prove that ABCD is a parallelogram. Now, let's have a bit of a conversation because there's a lot going on in this over here. Okay, we're proving that it's a parallelogram. Now, I want you guys to remind me, what do these arrows mean? What do the arrows mean? Michael, I'm going to tell you, I didn't draw it this time. Okay, so you can't say it's my drawing. Good. All right. Okay. Be very careful, guys. The arrows mean parallel. And as soon as we remember parallel lines, they're telling us that AD is parallel to BC. What kind of angles do we need to think of? What kind of angles do we need to think of? That's it, Lesego. Yay. Yes, good. Parallel lines, we need to think of fun angles. Good. Fun angles. Excellent. Hi, Chiparo, fun, but not fun. It's fun. Maths is fun. Maths is fun. Good. All right. Now, what do we know? What do these things mean? And I think somebody already gave it away. Was it you, Nicole, who already gave us this answer here? Somebody already gave us the answer. Who was it? Let me check. It was Caitlin. Caitlin already told us. What did Caitlin say? Good. Caitlin told us that the two sides means that they are equal. So we already have quite a lot of information. AB is equal to DC. Right. Now, this thing in the middle over here is also very important because what it's actually telling us is that this side AC, is also equal to side AB and DC. It's also equal. So what they're saying is AB is equal to DC, which is also equal to AC. It's an interesting bit of information, but Nicole, 100%, Nkechi, you guys are on the money. It also means that AC is common. We can see it. We can see that it's common. Now, parallelograms are made up of other shapes. What other shapes are parallelograms made up of, guys? You can see it. I know everybody can see it. What shapes are now I'm saying the word good. They're made up of triangles. Particularly, What kind of triangles? Nicole, don't be that guy. Don't be that guy. Not isosceles triangles. This one happens to be isosceles. You're correct. But what are these two triangles? What are we going to be proving about these two triangles, guys? That they are what? Not common. Guys, we literally just did it. Yes, Nicole. Yes, Kanyisile. That's it. Congruent. They are made up of congruent triangles. Okay. They are made up of congruent triangles. We've just, guys, trust me. Trust me. I didn't make you do congruent triangles for nothing. We were going to have to use them at some point. Okay. Now, we know that we are trying to prove that this thing is a parallelogram. Trying to prove parallelogrammism, right? I just made up a new word. Yes, that's it. Oratilwe. Good. That's where we're going to start doing those types of things. Okay. But in this case, we won't even have to go there because this whole thing will prove itself without us having to say that congruent properties of congruent triangles are congruent. We won't have to go there. Okay. But okay, let's look at the properties of a parallelogram, guys. We know that both pairs of opposite sides are parallel, and we know that both pairs of opposite sides are equal. Though that's the thing that we're going to be looking at in this particular triangle, or these two triangles. So I'm going to start. I'm going to say in triangle, and I need to make sure I'm mapping them out correctly. I'm going to go A, B, C. So triangle A, B, C. And in triangle, now I need to make sure I'm starting in the right place. Because I started at A and I went down, and AB is equal, I need to make sure that CD is also equal. So CDA, that's the way I need it. And in triangle CDA, I'm going to go back up in just a little bit. Nicole, I see you. You're like 100% on the money here. Good. In triangle ABC and CDA. Now, let's talk about what is what, guys. We need three things. Remember, we're proving congruence. What do we need? Oh, AC is equal to CA. Yes, good. Okay, we can start by saying AC is equal to CA, or we can just say that AC is common. We can start by saying that AC is common. Good. What else? Give me another reason, guys. Kanyisile and Caitlin, you're correct. We need reasons, but they also come with statements. So you must also give me statements. Good. Good, Nkechi. AB is equal to CD. And our reason, what is our reason? Okay, our reason is that it's given, and I'm going to read that just now. Good. Then Anotita says angle C2 is equal to angle A1. And I'm going to say that is incorrect. I'm going to say that is incorrect, Anotita. And the reason for that is because if you use C2 and A1, you're using the N property in fun. You're using the N property. And look at your two sides that you're trying to use. They are not congruent. They are not congruent. Leah, I'm not going to forget. Okay, I'm not going to forget. I will not forget, my sweetie. Hold on for me. All right. Now, look, guys, draw your N in fun properly. Remember where your actual parallel lines are. There are your parallel lines that create the sideways N or the Z. Now, look at it, guys. Which two angles are actually equal to each other? Good, A2 and C1. Now, Ivana, remember, you can't say, sorry, A2 and C1. Ivana, you cannot say that A equals C because the diagonals bisect. No, because what you're doing by saying that is you're using the property of a parallelogram. And you can't do that because we're trying to prove that it's a parallelogram. It's like in English, when you are trying to, like, they ask you for a definition. you can't use the word in the definition. You have to give us another reason. So you can't use the property of a parallelogram to prove a parallelogram. I hope that makes sense. Okay. I hope that makes sense. Okay, excellent. All right. So we can then say that A2 is equal to C1, right? And that is because of alternate angles. AD is parallel to BC. Good. I need one more reason. Oh, we have 3 reasons. I'm lying. Therefore, I can say that triangle ABC is congruent to triangle CDA. And the best part about this one is that because we already have an opposite pair that is parallel, and we've just proved that the sides are equal, and we've proved that both of these triangles that make up this parallelogram are congruent, then we can automatically say that it's a parallelogram. All right, what is our reason? What is our reason, guys? Good, Nicole. Good. Is it side? Yes, it is. It's side. It can't be side angle. And it's not side, guys. Be very careful. That's it. Who said that? Somebody said that first. I saw you in capital letters. Where are you? I've now lost that person. Where are you? Sipokazi and Sinoguche. Good. It's side angle side. Good. It does. 100% matters, Didi. Side, angle, side. That's the reason. Because of that, we can then say that ABCD is a palm. And our reason here is because opposite sides are equal and opposite sides are parallel. Okay. All right.